Good evening, ladies and gentlemen, and welcome to the Skywalk Podcast. We have a great show for you in store here today, including stories such as Earth's core slowing, NASA playing around with some nuclear engines, and the Lucy mission has a new destination. Let's jump into it. Before we get into the meat of things, of course, this is our little time to talk with each other, and so I have a few updates just so that we are all on the same page of what's been happening in the world of the Skywalk Podcast. The YouTube and TikTok shorts, which I'm sure you guys have all seen by now, have been coming in full force. I'm sure you've seen that. I hadn't done shorts or anything of the sorts before, and I wanted to see what it was all about. I wanted to really put a lot of effort into it and try to get a good amount of them off the bat once we started up this new season of the Skywalk Podcast. But you also probably noticed that this past week there was, I only think one short compared to multiple the weeks prior. And that is not anything on your guys' part. That is the fact that, school for me has started up, and so I have a little bit less time than I used to. Which means that there just may not be a million shorts like you've previously been seeing, but don't worry, I'm still planning to be doing those shorts and a few of them now that I'm starting to get a little bit of a rhythm of how the next few months are going to go. And for you guys, just so you are all on the same page with me, that schedule is going to go as follows. Space news, we will take the three main stories out of each week's podcast and make it into a short, that little bite-sized episode that I always talk about. Those will still come out on Saturday. But as for other shorts, other supplemental content, there will be one short coming out on Sunday and then one coming out on Tuesday. And so that should be the schedule. We should have more or less live recordings every Thursday, and then the actual episodes airing on Friday. The short bite-sized versions of Space News coming out Saturday, and then supplemental shorts coming out on Sundays and Tuesdays. And then we continue on the next week. So that's the new schedule. Hopefully you guys are okay with those changes. And if anything, those supplemental Sunday and Tuesdays are going to be the things that may not happen every single week. Again, college kid, so there is a lot that I have on my plate and have to do. I'm going to try to do the best I can, but at bare minimum, we will have the podcast episode and the little recap on Saturday. I also once again wanted to mention how much I appreciate your love and support on those shorts and on the podcast itself, and just all the content and ways you guys interact with me. I really appreciate it. You guys absolutely make my world. I love this little community that we've really started to build over the last few weeks especially. This new season has really brought a new life, and we have a nice little following base and subscribers happening, and it just makes me really happy. I don't care about a lot of things. I just really think it would be fun to have a nice community that we can all interact and hang out with, talking about space, just enjoying our passions. And you guys have been amazing, leaving comments, likes, watching everything, and I appreciate it from the bottom of my heart. I know I've been saying this like every episode, but I truly mean it and want you guys to know how much I appreciate it and look at everything that you guys do. Last little update that I have for you before we get into the episode is you probably noticed that I am trying to be a little bit less scripted. I'm trying to go a little bit more off the top of my head. I still have my notes, of course, because it would be impossible not to, but they're more bullet points. I haven't written out big, long scripts like I used to, meaning that it's going to be a little bit more raw and a little bit more of just me. Which hopefully isn't going to be a bad thing. Hopefully it actually allows me to be more expressive when I talk about things instead of acting like I'm just reading from a script. So hopefully you guys will enjoy that change to things as well. But with all that out of the way, we can go ahead and jump into our episode. Welcome to the Skywalk Podcast, Season 2, Episode 3. My name is Gavin. I will be your host for today's episode. And I am so excited. It's finally time. And you know what that means. it's time for us to embark on our journey through the stars. Sit back, relax, get a hot drink on this nice cold day. It's actually been really cold here, so a nice hot drink, get yourself a soft cookie, and of course, star cookies get bonus points. But let's jump into our space news. Our first story of the day is that Earth's core has been slowing down. Well, that's been the headline. Some of them have also been saying that the Earth's core has stopped outright, and I wouldn't say that one's as much true. But it has been slowing down, at least we believe so. Again, we're not fully certain, and there's debate going back and forth, but the Earth's core, we have a liquid metallic core, but that is surrounding a more dense solid iron core and ball that's in the center. Think of it like a ball bearing sitting inside of the Earth, inside of all that crust. And it has been slowing down, we believe, since at least 2009, actually. So a good chunk of time, it's been slowly and steadily slowing down, but we've noticed it more recently. We've gotten this information from reading seismic activity and following that into figuring out the core's speed. I'm not exactly sure how they figure out how to do that. I'm not a seismologist, I think is the correct word. But either way, seismic activity, that's things relating to like earthquakes, all that kind of stuff, is seismic. And they're able to see that the speed that the core is rotating is slower. Now, while all these headlines are making it very alarming, I want to assure you guys that we are in no danger. Both us as humans and us as a planet. The magnetic field is not going away. We are okay. And also, humans are fine. Earth's core actually tends to do this cycle, we have realized, about every 70 years. So every 35 years or so, it starts to slow down, and then it starts to speed back up. And so full cycle of slowing down, speeding up is about 70 years. And we've noticed this, and so we just might be in the slowing down portion, because the Earth's core rotates at a different speed than the outer shell, the mantle and all that whatnot, the outer layers outside of the core. They rotate at different speeds. And so you have a faster core that starts to speed up the outside, and then the core starts to slow down and meet up with that speed a little bit more. And then they meet, the core gets a little bit slower, things start to slow down, and then it ends up speeding up again. And that's kind of how we believe the cycle is going. And so something was floating around there. But yeah, it's still a little bit debated on, again, whether or not this is actually happening or not. We can't really get down to the core and find out and just ask it. But either way, if you've been seeing all those headlines and whatnot, don't be alarmed, we're okay. NASA has just funded a bunch of visionary projects. The NASA Innovative Advanced Concepts Program, or NAIC program, is a way for NASA to give funding to kind of revolutionary thinking in new eras of technology. Some of the proposals that have been funded under this are new telescope designs, such as using little satellites to create an interferometer system, as well as trying to use microgravity to actually create a full 50-meter in diameter unsegmented mirror. So unsegmented being it's one big solid sheet of mirror, which that would be absolutely revolutionary if we're able to do that. And so that's some of the funding. Other funding is pellet beam propulsion, which I was a little bit confused by this because it sounds like a Pez dispenser basically is what's launching things. But it basically sounds like they're using a high-powered laser to shoot little tiny particles out the back, and going by Newton's third law, equal and opposite reaction, that propels the spacecraft the other direction, or forward. So you send the laser backwards, you go forward. So that's another type of engine system that is part of this funding, as well as there's also been nuclear engine design proposals, which could be really useful. We know that nuclear engines are things, and nuclear batteries that power rovers and whatnot and other systems. It can be a really reliable system, But really only time will tell to see what these systems actually entail and if they are feasible for the future. Finally, NASA's Lucy mission has just added another object to its list, bringing its total destinations up to 10 asteroids. NASA's Lucy mission launched in October of 2021, so about a year and a half ago is when it launched, and it is embarked on a very long journey. It's going to meet up around Jupiter's orbit because it wants to study Trojan asteroids, specifically the Trojan asteroid systems that are around Jupiter. And this process is going to be a 12-year-long journey that this mission is. So it's going to meet the first set of Trojan asteroids in 2027, and then the second set of these Trojan asteroids in 2033. However, scientists have just added a new destination, and it's actually going to be the first stop on this mission. It's going to go see asteroid 1999 VD57. Try to say that 10 times fast. But this is another asteroid that is in the same area as Jupiter and all the other ones that it's trying to see. And the asteroid, we believe, is made out of silicate material and a nickel-iron base to it. So, kind of interesting structure to it. It's considered an S-type, I believe is the correct terminology. But in order to get there, Lucy is going to do some maneuvers in May of this year so that it can hopefully get within 280 miles on November 1st of this new asteroid. And for kilometers, that is 450 kilometers, which is really, really close for a spacecraft trying to get near this asteroid. And they want to do this in order to test out some systems before they get to the big meat of the whole mission and what their actual main character destinations are. They want to test out the Terminal Tracking Camera, or T2 CAM. And this is a way for the spacecraft to autonomously lock on to its target so that it can stick onto it and be able to use its cameras and gather data and whatnot and navigate as close to it as it can. So it's testing it on this new asteroid so that when it gets to its destination of those two sets of Trojan asteroids, it will be all tested and good to go. Those were some nice, good space updates for this week. A lot of NASA in the news this week, which is always kind of fun because near and dear to a lot of people, and myself included's heart, is NASA and everything that they do, especially the Lucy mission. If I'm not mistaken, that was built by NASA's Jet Propulsion Lab, which JPL is very much a dream goal for myself. So all that kind of stuff, those spacecrafts are really, really cool to me. But with all that said, let's move on to our object of the week. And what better object than Comet C/2022 ZTF? Now, I know that if you've seen the short that I made a couple weeks ago talking about this comet, some of this information might be similar, but we're going to go into a little bit more depth, and a lot of people also probably haven't heard about this, or at least they don't know that this is the official name for the Neanderthal comet. And so this comet was discovered on March 2nd, 2022 by Frank Masci and Bryce Bolin. Again, I'm sorry for my bad pronunciations, but they discovered it using the Zwicky Transient Facility in Paloma, I think it was the Palomar Observatory in California. Either way, it was in California. And because it was just discovered last year in 2022, Charles Messier did not discover this. I know I always add Messier in there just to have a little bit of fun with things because he's been our near and dear friend for this whole podcast. And so I still mention it, even in cases like this where there's no way that he could have ever discovered it. But why not? Just mention him because we love our Comet Ferret. But Comet 2022 is probably how I'll end up referring to it, some sort of way like that, is an Oort cloud object. And because it is an asteroid and it's constantly moving, changing location in the sky, I don't have an RA and deck, right ascension and declination location for you right now because by the time I'm recording this, once it's posted and once you actually end up listening to it, it will be in a different spot because it's constantly moving. So if you want to get those locations, then just whenever you want to go see it, look it up real quick and then you'll get your RA deck. As for the structure of the comet, it has a very green hue to it, green color when you see it in the sky and in photos, and that is because it has a diatomic carbon base to it, which is like 2 carbon atoms stuck together, and that makes it a green color. As for the location, again, really hard to say because each day it's going to be in a different spot, especially right now because it's going to be moving quite fast through the sky as we're approaching its perihelion. But if you're listening to this sometime around when this is posted and within the next week or so, look sort of around the dippers if you're in the northern hemisphere. So right now, I believe as the time of recording this, I believe it is actually in between the Little and Big Dipper, Ursa Minor and Major. Currently, the apparent magnitude for the comet is 8.34, but again, these numbers can start to be a little weird because this actually is visible to the naked eye, which is very exciting. It's not every day, it's not every lifetime that you're able to actually see a comet without needing a telescope, and this one is possible. It may not be as big, spectacular, like Don't Look Up movie style comet that you can just see in the sky, but you should be able to see the like fuzzy smudge of the comet in the sky, assuming that you're in a dark location. You're not seeing this in the heart of a city, but go to the outskirts, go to the countryside, shield yourself from light pollution a little bit, and you should be able to look up and be able to see it. And if that means that in a pair of binoculars or even a cheap telescope, you should be able to see actually a lot more of the structure to it, including that nucleus in there as well, which is even more exciting. There's not really too much cultural representation and background and history that is able to be found on this, because this comet also hasn't been around in a very long time, let alone it was only discovered last year. But the comet actually hasn't been to Earth in 50,000 years. So it has been quite a long journey for this little guy. Last time it was here, Neanderthals were walking the Earth. So it's changed a little bit since the last time this comet has been here. But like I said, it's an Oort cloud object, and due to the nature of its orbit and how it's traveling and all that kind of situation, this comet possibly will just never return again. It could be using this momentum that it's getting from this recent orbit around the sun and Earth and planets, and it is going to just go out and have a trajectory to leave our solar system. But if it doesn't and it is able to come back around, we think that now the orbit will mean it won't come back for millions of years. So this is a once and basically a forever chance to see this particular comet. It's been really bugging me because we've been able to see the comet for about a week or two now, and it's been bugging me. I haven't been able to see it. One of the issues is that usually at nighttime it ends up rising at around like 10 to 11 o'clock at night, and the best time to see it when it's highest in the sky is going to be sometime around like 3-4 o'clock in the morning, which is not a great time, especially when you have school and work and other things in people's lives, which means that I haven't been able to see it, especially because we've been getting snowstorms here in Flagstaff. This month we've gotten about like 5 feet of snow, and that means that there's been no night sky. But that being said, again, as of the time of recording this on Thursday, I'm probably not going to bed tonight, and I am actually going to go out and try to take some photos of this comet. I'm meeting up with another fellow amateur astrophotographer, and we are going to try to take some photos at about 4 o'clock in the morning tomorrow on Friday. And I'm very excited, but also a little bit horrified because it's going to be really cold. But I'm excited to see it. I've been wanting to see this. I might actually bring one of my optical telescopes just to get a little bit of a view on it so we have something to do while we're taking our photos. But I will, of course, keep you guys posted, because if I do get some nice photos, or just honestly any photos at all, of course I will be showing and sharing those photos with you guys as well. Moving on to our Q&A section. Just as a reminder, guys, if you have questions that you want answered by myself during an episode, just leave a comment on the podcast wherever you listen to it, or as a review if you need to as well, or on any of my YouTube shorts or videos, the podcast posting on YouTube. Tweet at me, anything like that, or on the Discord or subreddit. All great places. Leave a question, and if you have a particular way you want to be referred to by a name or username, anything like that, leave that there as well. And I will be sure to go through those, and we will answer those questions. But these were all taken from Reddit, the subreddit of space, and I wanted to go through a few of these questions. The first one is, what is a black hole? And a black hole is kind of this mysterious object that we've only taken 2 photos of ever, but mathematically they have to exist, and they have to exist in bulk. There's tons of them. But a black hole is basically an extreme bending of space-time, this fabric of space-time. It is bent so extremely that light cannot escape it. And so gravity, you can think of it like a big ditch, a big hole, that once things start to fall in, after a certain point, it takes faster than the speed of light to get out of it. And the speed of light is the speed limit for the universe, which means that there is no light at a certain point, and that's where you get the black hole portion of it. And that region of the point of no return, more or less, is called the event horizon. You can't tell, black holes very much interest me. But at the center, the thing that is actually causing this big bending in space-time, or this big hole, however you would like to describe it, because it's not a pulling, it's a falling, if that makes a little sense. But in the center, there's this little tiny ball. It's called a singularity, and you might have heard of that before. And the singularity is a mass that is infinitely small, but of infinitely great mass. It kind of just breaks laws of physics. It doesn't really make sense. Singularities are an incredibly mysterious thing that is just something theorized at this point, because again, you can't go inside of a black hole. But physics breaks down at a singularity, and it, to the point of where you cannot describe a singularity by the context of where and when, because it does not follow those connotations. Singularities, because of the principle of how they act and whatnot, and the rules that they do and don't follow, they have both always existed in the universe and have never existed in our universe, all at the same time. So, good luck dwelling on that one, but that is kind of the structure of a black hole. One fun thing about black holes as well is you get gravitational lensing, which is basically the light from behind it bending around so you can see it on the other side. Sometimes it actually makes a duplicate image on either side, which is really kind of cool. But again, that whole bending of space-time situation. Our second question is, well, what exactly are Saturn's rings made out of? And also, do they orbit around Saturn, or do they sit there and Saturn just rotates in the middle of it? And Saturn's rings are basically just icy rock. They're very, very shiny, and that's why we can see them, because we think that they're pretty new, like possibly 100,000 years type of situation, like really, really new, which means that dust hasn't settled on them, and they're really shiny. But it's mostly just ice, and that's what's reflecting the sunlight back to us. The range of size is anywhere from like a grain of sand to a size of a house. So it can range a little bit, but you have tons and tons of these objects, thousands, hundreds of thousands, I'm sure at this point. And we don't really exactly know why Saturn has these rings, but one leading theory is that it was actually a moon that got broken up. For some reason, it may have got too close to Saturn and it actually got ripped apart by Saturn's gravity. Maybe a collision happened, but one way or another, at least one object broke up into tons and tons of pieces, and then once things settled into a disk, as things rotate around a body, they flatten out, and now you have these rings. And if you've seen images of Saturn, I mean, admittedly, it's beautiful, so let's just get that out of the way. But you've probably noticed that there's rings, there's multiple, there's little gaps between this big disk that divide up these rings into different sections. Well, this is actually because Saturn has tons of moons, it has 79 moons, and some of them are actually within the rings. And when a moon is there, it moves everything in that orbit out of its way, which means that you get this nice little division inside of the rings, which is kind of fun. But as for that second part of the question, the rings do orbit around Saturn. That's actually how everything flattened out, like I said. And so they're just orbiting around. All these little particles are rotating around the outside of Saturn. They're just having a fun little time out there. Our last question of the day, what is a light year? A light year is a unit of measurement, not time. I know it's kind of deceptive of having the word year inside of that, but it is actually a distance, not a time. That's because the way that it's described is the distance that light travels within a year. So that distance that light travels, that is 1 light year, if that kind of makes sense. Light years aren't what we usually use in a lot of calculations in science. Typically we use parsecs, which is a different unit of measurement, and you can translate between parsecs and light years. There's a number, and then you divide or multiply, and you get your other number. But we're going to stick with light year, and it is a term that has been more coined for, per se, general public. It's an easier number and concept to understand than a parsec. Parsecs are just going to be too complicated for me to explain in this when we're just trying to focus on light years. But light travels at a speed of 300,000 kilometers every second, or 3 times 10 to the 8 meters per second. This means that in 1 year, it travels 6 trillion miles. That's how far 1 light year is. 6 trillion miles, or just shy of 10 trillion kilometers, 9.5-ish. If you want to get a little bit of scale for this, of what visually that would be, let's use the scale. This is something that I've used at the observatory before. If you use the scale of 1 inch, 1 inch is 1 million miles. Well, for our sake here, let's put the sun roughly at the size of a basketball here in Flagstaff, Arizona, and then let's plot the closest star to us. Proxima Centauri is about 4.3 light years away. And if we are to use that scale of 1 inch is 1 million miles, then Proxima Centauri is in Los Angeles, California. That's right. Almost 400 miles away by how the crow flies, or just over 600 kilometers away. On that scale, that is how far 4.3 light years is. So basically, that is a very large distance, a very large number. Hopefully that helps understand it a little more. I know light years, and especially when you're converting to miles and talking trillions, we're talking about numbers and concepts that humans can't really perceive. And at a certain point, I've learned this with studying this field, is that you just kind of accept things that, yep, okay, that is big. And at a certain point, yep, far. Our last section of this episode is, of course, our picture of the week. So this photo was posted on the subreddit Astrophotography by user We Are Crab People, which is one of the greatest names I've ever heard in my life. We Are Crab People posted this image of IC 2177, which is another name for the Seagull Nebula. The Seagull Nebula is very gorgeous, and they have done it absolute justice. It is a beautiful image. So much kudos to you. There's beautiful orange and blue colors within this nebula, a nice kind of arcing shape. It almost kind of looks like another version of an Orion Nebula. It has the very similar structure, especially with the dark nebula kind of shielding the crescent shape and nature of it. But it is absolutely gorgeous. And so this is a little bit about how We Are Crab People took the photo. They took 13 and a half hours of data over the course of 6 nights, and so that is all stacked together, and that is the data that you see in the final product. They use specific O3, HA, and S2 filters, that is oxygen 3, hydrogen alpha, and sulfur 2, and they're in a Bortle 8 sky. So this just goes to show that it doesn't necessarily matter what type of light pollution sky you're in. If you do it right, it does not matter. You can get around light pollution if you do it properly. And this photo just goes to show how you can do that. But in order to get this wide field of view, the telescope they used was a William Optics Red Cat 51, which is beautiful, because that is my pride and joy. That is the same telescope lens that I use, and actually the one that I'm going to be using in just a few hours to try to get the photo of the new comet. And so it's really nice. I love whenever people use the Red Cat. It just makes me so happy because I'm a Red Cat owner myself. But absolutely great job, We Are Crab People. Absolutely great job. It's a beautiful photo, so very good job. Alright guys, and just like that, we are at the end of our episode. I know it's a little bit shorter than other ones, but that's not necessarily a bad thing. It just means we didn't have as many updates and things like that. We didn't ramble as much, hopefully. But I still think this was a good episode, chock full of really, really cool information and concepts. If there's anything that I said that you'd like me to go more in depth on, just let me know. I will gladly go back to anything and try to elaborate. Maybe I'll even make it a little bit of a supplemental episode or something. Maybe I'll post a 10-minute YouTube video or something, really going into depth in a concept. Maybe you guys really liked black holes. Well, maybe we could even do a whole podcast episode on black holes and just dive into detail, different types, all that kind of stuff. So if you guys do want a little bit more on any of the topics that I talk about in these episodes, make sure to let me know, and I will be sure to do that for you guys. But also make sure to follow us at Skywalk Pod on basically every social media platform, including TikTok and YouTube. Actually, sorry, no, not YouTube, because that's just under the Zombefied Productions YouTube channel. But also there's no Instagram channel either. And also make sure to check out the actual website of Skywalk. I'm trying to build that up a little bit so that we have our podcast, our shorts, our merchandise links, and also a little bit of an astronomy blog and astrophotography. My buddy might actually be joining in writing on that. I know I haven't really posted anything outside of that first welcome message, but give me time. I'm trying to figure out how to blog and have the time to talk about the things that I want to talk about. But there will be some blog posts up there as well. So check out the website. Let me know your thoughts and anything that you'd like to see from this podcast and all of the subsidiary components of it. And the last thing I want to mention, guys, especially if you are listening all the way through to right now, well, first off, I appreciate you for sticking through to the end. But that also means you really enjoy this podcast and what we do here, which means that if I can ask one thing of you is to please, if you are able to, rate 5 stars, like, comment, even if it's just an emoji. Leave a review just with your favorite emoji, or leave a comment on a video with your favorite emoji. Something just as simple as that. Maybe just a fun word that you learned today. Just something that shows all these algorithms that people are engaged. That's how we really start to get recommended elsewhere than just through you guys. And make sure to subscribe for more content, again, on all these channels, especially the YouTube. That's where everything should be posted, is through YouTube, no matter what. Once again, thank you guys so much for all the love and support. This has been the Skywalk Podcast, bringing you your weekly dose of space news and facts. You've all been wonderful listeners, and I will see you all next week with another episode.